if. Okay, I'm going to teach you now a special, right? A special kind of word problem that's based on, that uses quadratics, but it's based on demand functions. So let's say you can sell, say, 75 cakes if you charge, let's keep the numbers really simple, $1 a cake. But if you charge $2 a cake, you sell 15 cakes. So what is the demand function here? That is, what is the function that takes a price and gives you the quantity? Well, we make our PQ table, and we have 1 makes 75, 2 makes 15. We get a slope of 15 minus 75 divided by 2 minus 1 is a negative 60 is our slope of a demand function. Then we plug in, we say 75 equals, I know it equals 75, minus 60 times 1 plus intercept. We add 60 to both sides, and that's going to give us 135 is the intercept. So our demand function d of p is going to equal negative 60p plus 135. And we can test that. Negative 60 times 2 plus 135 equals 15. And that's a check. Alright. So that's our demand function. But what I'm going to start talking about now is revenue. Okay? Revenue is how much money, right? Money. Money! Isn't money interesting? Cool? Something we really want? So revenue is how much money we collect from customers. And I think we want to maximize revenue, right? We want to make the most money. So what should we charge? So how can we take this demand function and create a revenue function? Well, the amount of money we collect is how much, by the way, you don't need to stick to that, such a small thing. Okay, and we might want a question mark on this. Okay, so the amount of money, the amount of money we collect is how much we charge, right, the price, times how many we sell, the quantity. So it's P times Q. So in the first case, right, so if we were to, say, add another column for this, okay, go in, add a new column on the right. We'll call it R for revenue. Okay, and this is revenue is 75, right? Because that's basically 1 times 75 equals 75, and this is 2 times 15 equals 30. Now, we probably don't want to charge $2, but we don't know. So let's take our formula for demand. So demand, D of P, is the quantity. Right? D of P computes the quantity sold. So we can create a formula that takes price and gives us revenue. We're going to do R of P equals D of P times P. Okay, now for our example here, the revenue from the price is going to equal negative, let me put that in parentheses, okay, because we take the whole formula, negative 60p plus 135 times p. But we can distribute that p, and that's going to give me negative 60p squared plus 135p. Important to distribute, right? Important to parenthesize. When you replace, always replace in parentheses. And that is our revenue function. And we can test that. You can try, once again, what happens if we do negative 60 times 2 squared plus 135 times 2. And we're going to get 30, exactly what we got here. So that's a check. Now, but we want to maximize. Well, this is a quadratic. And it is going to be, this quadratic, by its nature, is a negative a quadratic. And every negative a quadratic is shaped like this. So what we want to find, our revenue maximizer, is going to be the top of that, which is otherwise known as the vertex. So our job is to find to answer this question, what we have to find is the vertex. And we know how to do that from our last class. We're going to see that this is the h of the vertex, which is the x, or in this case the price value, right? Because p is the independent variable. H is b over negative 2a, which is going, in this case, b is 135 divided by, remember to parenthesize, negative 2 times negative 60. So the price that maximizes revenue here is $1. Okay, we can round it to the nearest cent, $1.13 is price. This is the price that maximizes revenue, $1.13. And now, if we plug in $1.13 into our revenue function, we get negative 60 times 1.13 squared plus 135 times 1.13, and that's going to give us 75, a little more than 75. It's got to be bigger than both of these, and it is. It's $75, and to round it to the nearest cent, 94 cents is the maximum revenue. So that's how much we can make. No matter what price we charge, that's how much we can make from our cakes. Okay? So, remember, prices are always positive. Very important. Prices are always positive. And, right, if you get a negative price, you've screwed up somewhere. It's an easy check. And the maximum revenue is higher than any other. That's why it's maximum. All right. So, that is a revenue problem.